I hope you are well and doing good. And in this video, we will start the sorting approach. And there are multiple sorting approaches like as the bubble sort, selection sort, merge sort, quick sort, heap sort. One by one, we will see all the approaches and all the method to sort the approach, and also we will discuss the time complexity, which is the best and which is the simplest. We will detail in deeply. Now, first of all, we will start with the bubble sort. Here in this video, I will discuss the bubble sort. First of all, what is sort and sort? Why it's needed to sort? If there is a large data and we have to arrange this data in a ascending or descending order, then we have to sort in this data. There are multiple data and we have to sort this either ascending order or either a descending order. Then we have to sort this data. Okay. Now, and this using a bubble sort, in this we will discuss the sorting here. Like as examples, then 2, 3, 10 and 12 and 1. Okay, there is a given data and we have said to sort this data using a bubble sort. In bubble sort approach, first of all say in each iterations check the two adjacent element if they are in a right way, then go ahead. If they are in the wrong positions, then swap them. Okay. Now, adjacent element means suppose array of I and array of. These are the two adjacent elements. Means if we will see here, the indexes value 0, 1, 2, 3 and 4, and 0, 1 are the adjacent element, 1 and 2 are the adjacent element, 2 and 3 are the adjacent element, and 3 and 4 is the adjacent element. In each iterations, it will be check the adjacent element. Now, here n is equal to, suppose n is the size of the data and this array n is equal to 5. Now, at the first iterations, it will be compared with the two adjacent element, means 12 and 2, and 12 is greater than the 2, then it will be swapped. Then it will be 2, 12, 3, 10, 1. Okay. Now, on the second iteration, it will be checked 12 and 3. Okay. Now, 12 is greater than and 3 is lesser than, then it will be swapped. Means these are not the right adjacent, it are wrong position. Now, then 12 will be swapped. Then it will be 2, 3, and it will be 2, 3 and 12, 10 and 1. Okay. Now, after these iterations, it will be 12 and 10. Then 12 is greater than the 10. Then it will be swapped. Now it will become 3, 10, 12, 1. That's fine. Now, after this iteration, it will be check 1 and 12. Then 12 is greater than the 1. Now it will be swapped. Now it's 2, 3, 10, 1 and 12. And here we can see the largest data among them, the bubble up at the last position. at the last position the 12 have been bubbled up, and this is known as pass 1. These all are known as pass 1. Here 1 and 12 has been the appropriate placement, but the remaining data has been not appropriate placed. Then we have required a second pass. Then on the second pass it will be checked 2 and 3. Then 2 and 3 means this is the right way, right position. Then no need to swap them. Now it's become 2, 10, 1 and 12. It's become a now again this the next iteration it will be 3 and 10. Then 10 is a greater than, then it's become as it is. Then it will be 2, 3, 10, 1 and 12. Okay. Now after these iterations it will be checked 10 and 1. 10 and 1. Then 1 is a lesser than, then it will be swapped. Then it's become a 2, 3, 1, 10 and 12. Now after this its iteration, next iteration it will be checked 10 and 12, right? And 10 and 12, then 12 is a greater than, then no need to swap them. Means this is the second pass, pass 2. Now and only these last two element in the second pass, only 2 element has been swapped at the adjacent. Okay. Now we have required another pass. It's a 2, 3, 1, 10 and 12. Okay. Now in the iteration, first iteration in the pass 3 and iteration first, it will be checked 2 and 3. This is the adjacent element, then no need to swap. Then it's become 2, 3, 1, 10 and 12. It will be as it is. Okay. Now next iteration it will check 3 and 1. Now 3 is a lesser than, then it will be swapped. Then it's become a 2, 1, 3, 10 and 12. And again it will be checked 3, 10, then no need to swap. Then 10, 12, no need to swap. Means in a past 3 there is a 3 element has been bubbled up at the appropriate place. Last 3 element has been bubbled up at the appropriate place. No. Okay. Now this is the past 3. Now we have required another passes, because this is not in a sorting order. Then in the next iteration in pass 4 it will be checked 2 and 1. Then 1 is a lesser than 2, then it will be swapped. Now 1, 2, 3, 10 and 12. And in this pass again it will be checked 2 and 3 is a 2 and 3 is the wrong position. No, this is the right position, 2 and 3. Then it will be not swapped. Again it will be checked 3 and 10, no need to swap. 10 and 12, no need to swap. Means we have a, and this will be pass 4. Okay. Means how many pass required? There is a 4 pass required. If we have a size of n, then we have, if size is equal to n, then we have a required and n equal to 5. Then how many passes has been required? 4 passes has been required. 4 passes has been required. Means n minus 1. Then time complexity of the bubble sort, order of n square. Okay, this is the time complexity. And now we will see the code for the bubble sort in our system.
In this main functions, and in this main function the array has been given, and this is the calling function, and this is calling function, and this function has been to write in the code. In this functions I am going to write the code. And how many passes has been required? Passes has been required n minus 1. Okay, then size minus 1 and I plus plus. Okay, in one pass it becomes j, and it's going to size and j plus plus. Okay, check if array of j is greater than array of j plus 1. If this is true, then swap them. Swap array of j and array of j plus 1. Okay, after this swapping, print the data. And I plus plus, and see out array of I. Now this is the function and write function for this, and this is the not the array, this is the reference of array element. Okay, now reference of array j is become 2. Okay, now already we are familiar with this approach. Okay, and temp and num1, and in num1 num2, and in num2 temp data. Okay, now check. Okay, everything is right. Now run this. Oh, that's a good. Here is a 1 2 3 5 10. This data okay, size. Now this all data 12 2 3 10 and 1. This is the in unsorted order, and after this there is a sorted order. Okay, and this is the code. Okay, and thank you for this. I hope कि आपको समझ में आया हो. Thank you.